name is Layal Husseini. My ID is 2022-1025. The course is Advanced Software Engineering, and my teacher is Dr. Abdulkarim Ashkar. My ID is 2022-1025. The course is Advanced Software Engineering, and my teacher is Dr. Abdulkarim Ashkar. My project is an AI-powered project planning platform. I will start by talking about the project through the document, then I will show the implementation. The platform is an intelligent system designed to transform unstructured project ideas into clear and executable plans. The user enter project idea, adds team members with their skills, and the system is automatically start analyzes the idea, assign rules, distributed tasks, and generates a project plan with a timeline. The goal of this project is to help teams move smoothly from an idea to an actual execution plan. And now I have seven bounded context, and then this bounded context starts to convert it to services or small microservices. First is idea management. Idea management service responsible for collecting project ideas and analyzing them using AI to turn them into actionable data. Then I have user and identity. User and identity manage users' accounts, roles, and responsibilities across the platform. The third is project planning. Project planning creates project plan, roadmaps, tasks, and timelines. Then I have team management. Team management manages uh, team members' data, skills, and organize them into balanced teams. After this, I have task management. Task management creates tasks, assigns responsibilities, rules, and tracks the status of each task. Uh, the, then I have progress tracking service. This is monitor project progress and dynamically adjust timelines based on the team performance. The last one is payment and subscription. Payment and subscription validates whether the user has an active subscription before the AI starts analyzing. Now I will talk about how these services communicate with each other. This is the most important part of my design. Um, Before I explain each communication, let me explain concepts I used. My system follows hybrid microservice architecture, combined synchronous request response for real-time operations and asynchronous request response and asynchronous event-driven communication for long-running and coupled process. Synchronous request response or synchronous communication means that the sender sends request and waits for response before continuing. So it's like a phone call. You ask a question and wait for the answer from other side. So I use this communication style when I need an immediate result to continue. Then I have asynchronous communication. So async communication means that sender sends message and moves on without waiting. It's not block anything or the user other side doesn't wait for the sender to send anything. It's just send and continuing doing other things. The receiver will process it when it's ready. Now for the technologies, I use some technologies. First is REST HTTP. Now I use REST HTTP when I in project planning to team management. Now in project planning to team management, I use synchronous blocking request response to REST HTTP. Here, this technology. One service call another services APIs and wait for the response. So project plan requires specific team skills and member availability from the team management. The team data is required immediately to continuing building. And I have other is idea service and payment service. For idea service and payment service, I use synchronous REST HTTP 2. So before starting AI analysis, we must wait to check if the process is completed successfully and wait for the response. So if it can't process, we can't proceed or we can't continue without this confirmation. So the second technology after REST HTTP, I use asynchronous request response, and I use asynchronous event driven. So asynchronous event driven, I use this or when it's mean when a service publishes an event saying something happened. So for example, here in user and identity, I have asynchronous event driven. And in task management, to communicate with the project progress tracking, I have event driven too. So in this, let us say task management broadcast task assigned or task status updated. So for example, task status updated. Any service that interested of this event will listen and react. The sender doesn't know anything, or the sender doesn't care who's listening. It's just so task management doesn't care about the receiver. It's just send an event. I don't care if progress tracking is reach or interact with this event. So this make the process or service loosely coupled. Now I have RabbitMQ. RabbitMQ is a message broker. Instead of service, let us say I have two services, service A and service B. And instead of service A calling service B directly, service A sends a message to queue. Then service B is listening on the queue and process the message when it received it. Now, these two microservices never talk with each other. It's just we have a queue in the middle, and we use this in asynchronous communication. For RabbitMQ, in between idea service and planning service, now I have idea service and project planning service. So this is an asynchronous non-blocking request response, and I used RabbitMQ. Idea management sends the analyzed project data to project planning via queue messaged broker. Now, AI analysis is a long running process. So the other service is not required from it to wait to wait the sender. It's just take from the queue. AI analysis is the long process, so we don't want to idea service to be blocked and waiting. It's just this is the idea. So the first service publishes the idea to the queue and returns immediately. The planning service picks it up from the queue when it's ready. This is just the idea simply. Now I have between a project planning team service between project planning and team service we use REST HTTP. Between planning service and team service I use REST HTTP too. The planning service needs to team member data immediately to build a project plan, so there's no need to waiting. Now I have task service and the progress service. So here I used asynchronous event driven. When task status is changed, the task service fires an event and moves on without waiting. So progress service is still listening and records updated automatically. The last one have is user and identity service. This service in this service I used the hybrid style, combining synchronous request response and asynchronous event driven. So login and token validation are synchronous because they need an immediate response. So when user login, we take the token and validation. We need an immediate response. So it's a very quick process. Then I have asynchronous event driven. When user register, the service broadcast a user created event asynchronously to notify other services. The design ensures each service is independent, so the system is scalable and communication style matches the nature of each operation. So I have synchronous where we need immediate confirmation and asynchronous when we want a loose coupling and performance. Show you the running environment. First, I started RabbitMQ using Docker with this command. Now, this command runs it as container, which acts as message broker between idea service and the planning service. And here I have four services: planning service, payment service, idea service, and team service running now using Spring Boot Bootcamp on the front port number. Now, each service is built with Spring Boot and follows MVC pattern. and share same core dependencies. For example, I have a Spring Web for REST APIs, Spring Data GBA for database operations, and H2, and I have Lombok. And for idea service and planning service, I added Spring AMQP for RabbitMQ integration. Now, if I start with team service, here I have controllers, model repositories. Now, for models, here is the model. Now I have entity annotation. This annotation maps it to H2, and I have data annotation. This annotation from Lombok replaces getters and setters. And here for repository, this line extending GPA repository gives all CRUD operations automatically without SQL. Now I have controller, team member controller. I have REST controller and request mapping controller. These define REST endpoints. I also I also used VO classes, this value objects. These transfer data between services. For example, team member VO. This class carries team member data from team service to planning service. Now, let me show you the communication. I will focus on audio service because it contains both communication styles. This is the idea service. First, I want to start with the synchronous REST. This services folder, I have audio service calls payment service and waits for its response before continue. This is blocking, so it can't proceed without confirmation. I have now this. So now audio service calls payment service and waits for response. So this is idea service class. Then I have messaging folder. This class contains audio attributes, and this is audio message reducer. Now audio message reducer class contains rabbit template. Now this is asynchronous rabbit MQ. Now after payment is validated, this single line sends this single line sends the audio the planning service. So the audio sends via queue the planning service and returns immediately without waiting. So this is non-blocking. Now if I go to the planning service, here is the planning service folder. I have messaging. This is the audio message consumer. So I have here Rabbit Listener. This Rabbit Listener automatically receives the message and creates the project plan. So this receives the message from a queue that audio service brought in the queue using RabbitMQ, and it creates project plan. So two services never call each other directly. Now if I open Postman, but before I also have event-driven communication between task service and the progress service. Now when task status is updated, task service automatically notifies progress service. So here is my Postman collection, which contains all the API requests for 7 microservices organized in correct execution order. First, I need to set up the data. I subscribe with user protier. Now I want to subscribe. If I validate subscription is valid and status is active. Now I want to go to the team and create team member. Now team member created successfully. Now I want to go to the idea service and submit a new idea. With user ID 1, I want to submit this idea. So now I can see the status is pending, not analyzed yet. After this, I want to go to analyze the idea. Now, using this endpoint, I want to go to analyze idea. Now, idea status converted to analyzing, and idea queued for analysis RabbitMQ, RabbitMQ, and planning service will process it async. So first, idea service calls payment service synchronously using REST and waits for confirmation that the subscription is valid. Second, now after confirmation, it sends the audio to RabbitMQ and returns it immediately with the status analyzing. So no waiting for planning service. This is non-blocking. Now if we go to the plan service, go to the plans and get full details. But before I want to get all plans, now if I get all plans, I have this idea, I have this plan and this idea. I want to go to the full details plan. So here I have team member. So planning service calls team service synchronously using REST and returns both plan and team member. Here is team member and here is project plan. So this is the details together in one response. So this is synchronous communication between planning service and team service. So and here when get all plans, now I check a plan directly. So now new plan created automatically because planning service was listening to Rabbit MQ and processed the messaging in the background. So no need to create plan using this endpoint and no need to direct call. A new plan was created automatically from the Rabbit MQ after planning service listening to Rabbit MQ and take audio from the queue was sent from audio service to Rabbit MQ. Now I want to go to the task service. This is the task service. I want to go to create task. Now I move to event-driven communication. First I create task. So this is the task. And I want to go to the task or update task status. So this is notifies the progress service. Now when I update status, now task status is completed. So task service automatically sends notification to progress service. Now if I go to the progress service and get to all reports at any point. So this is the task status completed. So here in the progress service, a record was created automatically. Now after receiving the notification from task service, no manual call was made. So without any manual call, this record created successfully. So this demonstrates three communication styles working successfully: synchronous REST, asynchronous RabbitMQ, and event-driven communication asynchronously. Illustrate how I deployed my team service microservice using Docker Desktop. I containerized the Spring Boot application, created a Docker image, and ran it inside Docker container. Before starting, I stopped the Spring Boot application running from the IDE, make sure that the service is running only inside Docker. So here is team service is stopped. Now I created Docker file. So this Docker file has two stages. The first stage builds the application using Gradle and JDK17. So it copies the source code, gives permission to the Gradle library, and runs boot jar to build the jar file. The second stage uses only GRE17 to run the application. I also exposed this port number because this port used by Spring Boot application inside container. Now after I created Docker file, I built the Docker image using this command. So I created Docker image using this command. And this is Docker desktop. This is Docker image. So here we can see that the team service image was created successfully with this size and 15 layers. Each layer represents one step in Docker file. Then I ran the container use this command. So this maps port 9003 on the container to port 8081 on my machine, so I can access the service from outside the container. So this is the container, team container. The container is running successfully inside the desktop completely and isolated from the host machine with its own environment. Now if I start or go to the Postman to verify service is working correctly, I tested using Postman. I want to create, if I go to team service, I want to add team member. Now I stop bootran from the IDE. So I want to verify that this worked correctly. I want to create a new team member. So I create this team member. Now team member created successfully and I want to get all team members. So this is all team members. Now the port is 808081, but my previous port port is 9003. So now if I change the port, this is failed because I stopped the IDE from running. Now the service is responded successfully, which confirms that containerization was done correctly and the service is running inside the Docker. And deployed was run successfully using GitHub Actions and Docker Hub. So this is GitHub Actions. Here I have planning service and team service, and workflow runs successfully. I have planning and team service. Now this is workflow files. It has several steps. First, it checks out the code, then steps Java JDK 17, builds the jar using Redel, logs it into the GitHub using credentials, stores as GitHub secrets, and finally builds and to the Docker push the Docker image to Docker Hub automatically. Now this is Docker Hub, and these services push automatically using GitHub Actions. I have team service and the planning service. So this workflow is triggered every time I push code to the main branch on the GitHub. So here we can see that workflow can run successfully, and the image was built and pushed to the GitHub without any manual work. This is full CI/CD pipelines. So I containerized the team service using Docker with multi-stages Docker file. The container runs independently without any external dependencies and with GitHub Actions. Now Docker Hub and the entire build and deployment process is fully automated.